this example, my leading coefficient, it is a phantom 1 right now. I'm going to force it to be that way, by the way, because as long as it's a phantom 1, then I can just factor this out pretty quick. I don't have to use the quadratic formula, so I'm not going to on this one, okay? But I do need to make this all equal to 0. That's crucial. So let's take this. Again, I'm not really treating it like an inequality, but an equality. What I'm going to do is force this to equal 0. So to do that, I would have to subtract 10 w's from both sides. So minus 10w. But also, I would have to subtract 24 from both sides. So minus 24. I know that's kind of weird looking on the left. So I'm gonna arrange this in descending order. So I'd have the w squared minus the 10w, and then minus the 24. Okay, now this is all in an effort to keep that coefficient of w squared a phantom positive 1. I don't want it to be negative. So for those of you that subtracted w squared from both sides, yeah, you gotta take that into account. You can't just say, well, it's just a phantom 1. No, it's a negative if you subtracted w squared from both sides. But the way that I've done it, I forced this to become phantom 1, which means that when I factor this out, which is what I'm going to do, into two binomials right here, that's going to equal 0. I can do it directly. I don't have to worry about that negative 1 in the front. So let's see, 24, these would be w's. And then my negative 24, two values that add up to negative 10, 6, and 4. Nope, that's not going to work. 12 and 2. Okay, the 12 would be negative, the 2 positive. So I get w minus 12 in the w plus 2. And then those two factors, as usual, if I could get these to equal 0, then I would have a true statement. So if I could get w minus 12 to equal 0, I'd get truthfulness out of this equation. So I would add 12 to both sides, and I get w equals positive 12, which this means if you were to replace 12 into these w's here, you'd get a true statement, but it's the equal part of that true statement. Well, let's try the other one. So again, if I can make w plus 2, if I can make this equal 0, then I would still get a true statement. So minus 2 from both sides, and I get w equals negative 2, right? We zeroed out these values. Now again, this means that if you replace these w's with negative 2, you'd still get a true statement, but that's the equal part of that true statement. So now that I have that, let's go ahead and graph this up. So there's my graph. Are you required to show a graph? No, but I like it. It helps me with the intervals. Now over here to the right would be 12 of 0 to the right of 0, and then the negatives to the left, so I got a negative 2 just to the left of 0 there. And yes, I do not care if they're proportional. What I see up here at the top is that the inequality, now this is the part that's important as well, the inequality showing that it's equal to, which means that these will be closed circles at negative 2 and 12. So now that I have that, I have some intervals to check. This one to the left of negative 2, and then in between negative 2 and 12, and then to the right of 12. So let's get to checking. I'm going to go back to my original inequality, which I recommend doing, always using the original, but you can use the one that you forced to happen from the principles of equality. Just be careful if you do. So mine shows w squared should be greater than or equal to 10 times w plus 24. Now I just need anything to the left of negative 2. This time, just because we've done it before, I'm going to choose, you can say it's an easy value to work with, but I'm going to choose negative 5. Negative 10 also would be a pretty easy one to work with, right? But I'm choosing negative 5. So I've got negative 5 squared should be greater than or equal to 10 times negative 5 plus 24. So I got my question mark right there. And I get 25. And I get 25 is greater than negative 26, it looks like. Now, 25 positive is definitely greater than negative 26. That's true. So I'm going to put a check mark on that one. All right, so that one's true. Now, like I've said before, it should alternate, which means if this one's true, this one should be false, this one should be true. But we're going to make sure, especially since that middle value there is 0. So I'm going to use 0 on this next one. We're saying w squared should be greater than or equal to 10 times w plus 24. But now I'm going to test this with 0. So it'd be 0 squared greater than or equal to 10 times 0 plus 24. This gives me 0 is greater than or equal to 24. Now this is checking, so I got my question mark. This right here is false. 0 is definitely not greater than, it's definitely not equal to either 24. So both of those don't work. I got my X over the interval there. Yeah, let's check this last one. So we got W squared should be greater than or equal to 10 times W plus 24. I just need anything to the right of 12. I'll choose 20 just because, I'm sorry. I'll choose 20 just because I'm going to let the calculator, I guess, do all the work anyway. So not 150. 15. So I got 15 squared should be, in question mark, should be greater than or equal to 10 times 15 plus 24. Now 15 squared, I believe, is 225. And this would be greater than or equal to 150, 170, make it 174. That right there is true. And so, yeah, we get a true statement. I got my check mark there. All right, now be careful because even though we just graphed and we'll pretend like we enjoyed it, it's not done, right? Because it wants the interval. Right, we did so much work, and it's good work, but make sure you put the actual interval on this one. This is something that we've seen in the past where students miss this interval notation. They do all this work, and it's great, but they miss the interval. So don't forget it. Okay, so we know the orange one is good. So I know this goes all the way from negative infinity, and then it will stop at the closed dot, which is at -2.
Bracket.
That's included, yeah. So we got a square bracket. And then we're going to unite this because the purple one is false. And then starting at 12, which is also included, so square bracket. And then this one also goes, the blue one, goes to infinity, which is never included. And these are our interval.